Climate change. The words have become as inescapable as climate itself. Some people see recent heat waves and killer storms as hard evidence that humans have destabilized the world's atmosphere. Others look deep into Earth's history and see ever-changing conditions, including periods that were even warmer than today. To them, climate acts on its own, not on the human stage. Many others aren't sure what to believe. They listen to both sides and hear evidence of heat waves in Siberia, cold snaps in Florida, and wait for science to reveal more. For climate is complicated. How do we know how it's changed in the past, or if it will be different in the future? How do we know what it means to us, to our livelihoods, and the places we live and love? For answers, some scientists are looking deep beneath the frozen surface of an Arctic lake. Under Alaskan ice, and in natural archives scattered all over Earth, scientists are learning to decipher the book of the past. Using techniques that allow them to read buried climate records more and more closely, they're taking a new look at patterns both global and regional. They're learning how changing climate has interacted with human communities. And inevitably, they're looking to the future too. For if our planet has a fever, we won't know until we take the Earth's temperature, until we delve more deeply into climate's past. The climate system is made up of all of Earth's atmosphere, oceans, and living things. Our planet is infinitely diverse, with starkly different climates from place to place. When climate changes, the effects can differ dramatically from here to there. Climate is ever-changing over vast timescales. Even the fastest changes may take a human generation. But memories are short, and the weather from year to year is variable, so it's difficult to recognize the underlying long-term trends. Even historical observations over hundreds of years don't capture the range of changes that the geological evidence shows took place. To understand climate and climate change, we need a perspective that transcends the space and time of our daily human experience. We need a long-term and global view. We need a view that goes beyond the heated, politically charged debates of today. But to get that view, scientists first have to get to some remote places. On a cold spring day, the immediate concern for an intrepid team of researchers from Northern Arizona University isn't the climate. It's the weather, which in the tiny hamlet of Coldfoot, Alaska, is threatening to derail a set of complicated plans. 100 miles north is frozen Shannon Lake, where the scientists hope to extract a priceless record of the Arctic's past climate from deep beneath the ice. But getting there is by no means a sure thing.
This is Coldfoot, Alaska, and we'd rather be at the lake getting mud, and we'd like to be leaving on this plane.
There's no road to Shannon Lake. Yeah, we're more than 100 miles south of the lake, and there's a lot of topography and a lot of weather between here and there.
And we're also waiting for our core tubes, which apparently missed the drop-off here.
This is field work.
This is typical. You do your best to prepare, and that includes the contingency planning as well. It's always fun when you deliver the core tubes filled with mud at the FedEx office, and they ask you, what's inside? You tell them, well, it's mud, and they wonder, why did you come all this way just to get mud? Don't you have any mud there in Arizona?
The project Darrell Kaufman and his collaborators have in mind is an example of how scientists have been studying the past to better understand the present and the future. They're trying to nail down just how temperatures fluctuated in past eras. If they can understand how they did and why it happened, they might be able to help society make some important decisions for the future. We all know that weather can change frequently and often unpredictably, but climate too is something that varies over time.
Climate naturally varies. We've had colder times than we have today. Little Ice Age, for example, just recently. We've had as warm or possibly warmer times than today. We've had periods of the Earth's history when CO2 levels have been higher than today. We've had periods of the Earth's history when CO2 levels have been lower. We live on a dynamic planet.